Now we'll take a look at preconditions. The first precondition in this source file is on the class constructor, and you can see the require clause is already highlighted, and the require clause tells us that there's a precondition on this particular routine. And the precondition in this case is that the clients of this constructor must supply a capacity greater than 0. Now the capacity in this case sets how deep we want to allow our stack to go. Okay, so should the the client supplies a value that is less than 0, then the routine will fail with an assertion failure. Now I should point out that Oxygene will allow you to supply your own failure handlers, so that if an assertion does fail, then you can log that should you wish to, or you can raise an exception. Now I recommend that if you want to use class contracts in conjunction with test-driven development, which is a good mix by the way, then you probably will want to get it to throw an exception, because otherwise your test runner will just carry on. By default, assertion failures aren't exceptions, so unit test runners tend to carry on regardless. So you will need to sort of step in and get it to throw an exception so that your unit test runner will stop on an assertion failure. Okay, so the other thing to notice with this routine is that because the precondition specifies that the capacity has to be over a certain value, then we don't need to test for that in the actual body of the code itself. There is no code in here that tests if capacity is greater than whatever. So that's saved us some code. And of course the other thing is that we now have a piece of executable documentation in this routine. It's clear to anybody that looks at this routine that to call it safely and correctly, then they must supply a value that's over 0. Okay, so we'll have a look at some more preconditions before we go on to the post conditions, and we'll see that the three routines here, get item, put item and remove item, they all have a precondition. Now get item is only legal to call get item if the stack isn't empty, as specified with this precondition here, not is empty, and you can only put items on the stack if it's not full, as is specified by this precondition here, and the remove item has a similar precondition to get item. So all these clauses, all these prerequisites tell you how, or explain to any clients of this class, how it is safe to call these routines. Well, take another look at the class invariants now and see how it fits in with the pre and post conditions that are applied to methods and when the class invariants are evaluated. So the first time that the class invariants are evaluated, it will be after the constructor has successfully completed. So we're assuming that the client for this stack class gives us a sensible value for capacity which meets the precondition, which remember is an obligation of the client and a benefit to the actual class itself, or the constructor in this case. Assuming that that's what's happened, then the constructor will ensure that the capacity of the stack is set to what the value that set to the depth at which the client has asked for. It will ensure that the backing store has been allocated by making sure that it's not null. The assign method is a runtime method of Oxygene, which makes sure that a reference is which will return true or false if depending on whether a reference is assigned or not. And because this is a brand new class, then really it should be empty, so we're going to make sure that is empty returns true. Now at this point, after the post condition, then the public invariant is evaluated for the first time, and if the class isn't in the correct state, then based on these assertions, then we'll get an assertion error, and which will indicate that the class is in an invalid state. So the next time that the invariants are evaluated is just before a public method is executed. So if put item or remove item are called, then the invariants will be evaluated before the method is entered, and then the method's preconditions will be evaluated. So we go down to put item here. The preconditions will be evaluated, the method body will run, the postcondition assertions will be evaluated, and the public invariants will then be evaluated once again. Now I should point out that that it is perfectly okay for a method to invalidate the class invariant while it's executing, as long as it ensures that the invariant is the class invariants are put back to the correct state on exit. And I should also point out that the class contract system in Oxygene is also thread safe. With all these assertions being evaluated left, right and centre, then you can imagine that's going to have a fair amount of impact on an application performance, and that's correct, it certainly does. The class contract system is designed to be a testing and debugging aid to ensure that you're happy with the way that classes interact with each other, and also to, as I said before, to provide like a form of executable documentation. When you're ready to ship the application, then you will probably want to turn off the assertions so that it's just the method bodies that are actually being evaluated, not the pre and post conditions. Now I believe what a lot of Eiffel programmers do, or Eiffel developers, is that they ship two versions of their application. They'll ship one with assertions turned on and another one with assertions turned off, so that if the end user of the application has any problems, then they get them to run the version with assertion switched on, and see if that throws up any problems, which then helps them find where the error has occurred and obviously fix it. Whether you want to do that with Oxygene or not is up to you. It's certainly something I would consider doing. Well, I hope this screencast has shown you that the class contract system in Oxygene can help you write more reliable software. Thanks very much for watching this screencast, and hopefully I'll see you in the next one. Thanks very much indeed. Thanks. Goodbye.